Hello and welcome to this video presentation about the protection against electric shocks. My name is Martin Lavachka and in this video I'm going to talk about the risk related to current and how to protect yourself against electrocution. Before starting, I want to mention that in this video we are going to deal only with 50 and 60 Hz alternating current, which is the most dangerous electrical current in terms of physiological effects. Okay, let's start. So, what is electrocution? How do we define it? Electrocution is a fatal electrical shock. What is an electrical shock? It is a physiological effect resulting from the passage of an electrical current through the human or animal body. Let's review some facts related to electric shocks. 70 million homes in Europe are electrically unsafe. 40% of fatalities in electrical accidents at home affect children under 9 years of age. In the UK, 350,000 people suffer serious injuries each year due to electrical shock. In the United States, electrical shocks are the fourth most common cause of industrial deaths, and from 2000 to 2015, there were approximately 61 deaths per year due to electrical shocks. It is estimated that 627 deaths occurred in Brazil in 2017 due to electric shocks. In France, 3,000 people suffered electric shocks in 2018 and 40 died as a result. In India, 9,606 people were reported to have died due to electric shock in 2014. As you can see, insufficient protection against electric shock is a serious problem around the world, and educating people about this risk is very important to maintain safety during all our activities at home or at work. To what extent is the current danger to the human body? The degree of danger to the person depends on the magnitude of the current passing through the body, the parts of the body through which the current passes, and duration of the current flow. The IEC 60479-1 publication defines 4 zones of physiological effects depending on the magnitude of the current and the duration of time. In the AC-1 zone, where 0.6 milliamperes or less passes through the human body, probably a person will not even notice this. In the AC-2 and AC-3 zones, a person feels that the current passes through the human body, the muscles may begin to contract. The degree of risk depends not only on the magnitude but also on the duration of the current flow. Currents over 40 milliamperes can be dangerous for the human body. This magnitude can already cause serious injuries and even death. Every time a human body comes into contact with a living part, there is a risk of an electrical current flowing through the body and returning to Earth. Contact with the live part could be directly by touching a live wire with damaged insulation, for example, or indirectly by touching a faulty device. The risk increases even in humidity because the skin's resistance decreases with humidity. so more current is likely to pass through the human body. Water is an electrical conductor, so electricity can flow through it from damaged wires to the human body. When the electrical installation does not comply with the standards and without adequate protection devices, there is a risk of electric shock. Since we are familiar with the risk of electric shock for the human body, now is the time to find out how to protect yourself against it. There are three principles to protect people against electric shock. The first principle is to make bare leaf parts inaccessible and ensure that the electrical installation is protected from water. This implementation helps protect against direct contact with live parts. The second principle is to implement an earthing system, or in other words, connect all metal parts and exposed conductive parts of electrical equipment to an earth electrode to maintain it at the earth's potential. This implementation helps protect against electric shocks from indirect contact. The third principle is the installation of highly sensitive residual circuit devices, or RCDs, which is the maximum protection against direct and indirect contact. The RCDs trips instantly if contact is made with a bare wire or faulty device. RCDs protect against electrocution when their sensitivity level is less or equal to 30 milliamperes. We have reached the end. Now you know the risks related to current and the basics of how to protect yourself against electrocution. Thank you so much for watching. Stay tuned for the next video where I will talk in depth about RCDs.